Good day everyone, this is Anthony Arguelles of BSIT23. I want to show what the lesson is all about. The power rule. In calculus, the power rule is used to differentiate functions to form f of x is equal to x is equal to r, or even whenever r is a real number, since differentiation is a linear operation on the space of differentiable functions. Polynomials can be also differentiated using this rule. It can be used for the power rule like that, even though you just look at the numbers in the exponent. So these are examples of the power rule. So this is written as f of x is equal to x to the 10th power. Then I'm going to read it for the power rule derivative rule. So f in the first power of x, then it equals, then you write out from there in the exponent, so 10x, and when the 10 minus 1 in the exponent, that's 9. So derivative of f1 of x equals to 10 times x to the 9th power. So very easy. Let's proceed for the letter B. G of x is equal to x 5 halves plus 3x plus 4. So you're gonna have to do, if we for the power rule there, then 5 halves will come right out from there. Then you just copy there in the x, then 5 halves. We will subtract into 1 to the exponent, so 5 halves minus 1. So this is the new exponent. Plus if you multiply by constant, nothing really happens to the constant. Just derivative part of this variable also. So just copy the 3 here, then so the 1 will come out from there. This x there, so x, so 1 minus 1, so will be 0 there. Then lastly, the 4 will be the exponent there. It will be 0. Then 5 half, and we're going to do, come back for the second. So this will be the power rule there. 5 halves x, then in the exponent 5 half over 1. So will be full of fraction there, and it will be 2 halves. So 5 minus 2, it will be 3 halves. It's equal to 3 halves. Then plus 3, we can write out for there. Damn it. So 3, that will be 1, and the exponent here, so cancel it. So will be 1 plus 0, and it will be all together. So 5 half x, then 3. This is the answer there in exponent for, then plus 3. So this is the answer. So even though if you finding the exponent, because always it may be negative 1. So 5 half, it will be 5 half minus 1. It will be in fraction the full fraction of 2. So 5 over 2 minus 2 halves is equal to 3 halves. Then x will be the exponent of 1 will be 0. It will cancel it, and then 4 it will be 0. There will be no exponent. So this is c of h of x is equal to 1, the root of 3, square root of x. We're gonna do for this number there. So it will be 1 x of 1/3. This will be the exponent. Then kaya babaguhin natin to at kailangan natin sa variable natin. So h of x is equal to x. It will be negative 1/3. This is the new exponent, and will be right derivative of power rule. So right now from the negative 1/3 x, and will be exponent of negative 1/3 will be minus 1. It will be the full exponent will be 3 cubed. Then and we'll see there negative 1/3 x is equals to 4/3 or 4 cubed. Is because 1 negative 1 minus 4. The next we'll really answer this is negative 1 3x 4 cubed. Then putting a radical notation there, it will be 1 3. Then cube of 3x, and it will be the 4x exponent. So that's radical notation there. So this is the power rule there. It was some easy a lot, or even though really hard, trying hard and be practical. So
the power rule. The question is asking what is the derivative of x cubed. We can use the power rule where n equals to 3. D over dx change the value of n to 3. So the answer is 3x squared.
So all we're gonna to do is the constant multiple rule. So this will be 2 for the numerator and x will be the denominator. So x will be always denominator. So we'll be proceeding to the same singular form there. So 2 times 1 over x. It will be negative there is equal to x to the exponent to the negative 1. So you have gonna do for the equation is 2x negative 1. So you're gonna have to do is for the power rule is you bring that to x from the denominator and it will be negative. So 2. And it will come out right out from there of 2. So negative 1 minus then minus 1 also will be negative 2. And with the answer for the constant multiplication will be equals to negative 2 over x squared. So this is the constant multiple rule.
Multiplication by constant rule. First, we have an example 2 over x. We need to simplify it into a 2 times 1 over x. which is also known as x to negative 1. Well, our new equation is 2x into negative 1. In this case, we need to use a power rule. We need to bring down x into a denominator as a denominator, and we need to multiply the exponent negative 1 into 2 and subtract negative 1 by itself. So we have negative 2x into negative 2. Well, for now, that is our distributive function. And to have a positive fraction, we need to we need to bring down x as a denominator and x squared as a denominator and 2 and this. So we have a negative 2 over x squared.
Okay, let's start. Let me give you the reciprocal rule example. The example is here. Okay, let's find the derivative of the denominator of x cubed. The derivative is, then copy the denominator as it was, and put the squared on the top right. Okay, after we find the derivative, let's simplify it. Copy the numerator, then x cubed, ito, dalawa, is x6. Okay, then let's cancel this and put it to the denominator. Is equals to 4. That's all. Thank you.
Okay.
Bilis.
The product rule. Using the product rule, f of x times g of x equals f of x times g of x plus f of x times g of x. Example, h of x equals x squared times x cubed plus 4. X squared is equal to 2x and x cubed plus 4 is equal to 3x squared. So, 2x times x cubed plus 4 plus x squared 3 times 3x squared equals to 2. The value of 2x times x cubed plus 4 is equal to 2x raised to the power of 4 plus 8x. And the value of x squared plus 3x squared is equal to the 3x to the 4th power. So, combine like terms, 2x raised to the power of 4 plus 3x raised to the power of 4 plus 8x. Then add 2x to the 4th power plus 3x to the 4th power is equal to the 5x raised to the power of 4 plus 8x.
Rule, or also known as the outside-inside rule. For example, h of x equals f g of x. For finding the derivative of each, the f is the derivative of outside, and g of x is evaluated at inside. While times g of x is the derivative of inside. This is the chain rule for finding the derivatives.
Sum and difference rule. For our formula for sum and difference rule, we have f of x plus g of x is equal to f of x plus g of x. For difference rule formula, it's f of x minus g of x is equal to f of x minus g of x. For example, on sum rule is f x is x to the third power plus x to the seventh power is equal to x to the third power plus x to the seventh power equal to 3x squared plus 7x to the sixth power. We get it from x to the third power and x to the seventh power. We multiply exponent by on x, then we get it 3x and we get 7x. Then the exponent we minus the original exponent, or we subtract the original exponent by 1. That's the sum and difference rule